Alright then, this morning we have something I got several years ago in my quest for, I don't know if you call it the perfect inverter. And this thing is a Terado, Terado model 50-133-3A. It is a 900 watt, 1500 watt peak intermittent, 117, actually it's 105 to 125 volt, and it accepts 12 volts DC. It is supposed to output 60 hertz. I'm not sure exactly why, but I do not get 60 hertz out of this thing. I get 50. The controls are what you see on the front. There is an on-off button. There are 4 30-amp circuit breakers, or I'm sorry, fuses. I believe these are actually in parallel. And then there's a voltage selector switch. The voltage selector is 105, 115, and 125 volts. And on the side of it, there is 3 outlets and a place to hook up the negative terminal. The negative terminal goes to the case. 2 of the outlets are marked load, 1 is marked remote. Currently I have one plugged into a small drill, and the other one is a suicide cord connected to my handheld oscilloscope. So, and I have it hooked up to a car battery, just a plain old car battery, not a deep cycle. I'm not planning on running this off of that, and it's running through some 6 AWG wire, which can handle for this length about 80 amps. Theoretically this thing should only draw between somewhere around 70-75 amps to output the 900 watts. So I'm going to turn it on. And you'll notice that we have the selector set to 115 volts, and that's setting, it says 120. I had to mess with try to calibrate it. It's only really accurate at 105 volts. Every other one is not correct. Now it's on 125 volts. Here's what the output waveform looks like. It's kind of a messy sine wave. And let's see if you can see this. It is drawing with no load. It is drawing a little less than 20 amps DC. So if I take this drill and the amperage draw has gone up to 27, just under 27. Now it's going down as this thing speeds up. The battery that's hooked up to this is kind of tired. if we hook it up at 105 volts, 115, 125. This device, and I'll be opening it up and showing you the insides. This device has no computer control in it. It is basically made up of discrete components. There's no ICs in it at all. It uses basically a large number of, I guess are transistors. I'm not sure because they have a proprietary part number on them and I can't find any information. Then there is 2 giant transformers in here and some things like resistors and capacitors, and that's it. There's not much in here. So I'm going to turn this off and open it up and we'll look inside. Okay, so as you can see, there's not much in the way of sophisticated electronics in this. We have the power switch down here, which controls this very large solenoid. There is a bank of what I'm guessing are transistors. I mean, they could be MOSFETs or something like that, but I have no way of easily telling, at least not without taking this thing apart. The selector switch is down here, and basically the way this works is that there's different windings on these transformers, and based on whatever voltage they're getting out, you can select. Like if you've got a device that's putting out about 14 volts, then some of these measurements might be a little high, like you might get 130 volts, and so you bump it down to the next lowest one. And as you can see here, the circuit breakers are in parallel. The voltmeter, a 115 volt fan. I personally would have used a 12 volt one, but whatever. There are some very large 20 watt resistors whose purpose I'm not exactly sure. I do not have a schematic for this. I could not find any useful information about it. The closest information I could find was it was mentioned in a paper put out by NASA that they were going to use one like it to provide AC power at some remote location, I think in Africa, for some project. The parts that I replaced when I got it were these capacitors and this across the line capacitor. There is no ground terminals on the plugs, even though they're 3-prong. They are not grounded to anything. The grounds are completely cut. Someone told me the type of oscillator this thing uses, and if I can find it, I will put it down here somewhere. That's kind of it. The purpose of this thing is it's something you would probably install in a work vehicle, or you would put it on, you know, some kind of van that needs AC power, or at a remote location that uses solar cells and large flooded lead acid batteries. There are an enormous amount of screws that hold this lid on. And I mean, that's about it. It works. It's just big and heavy. It weighs about 38 pounds. I got it from eBay. I paid, I think, $40, which included shipping. I think someone was just trying to get rid of it. And as I said, it only seems to put out 50 hertz. I'm not sure why. I was told that the closer this thing gets to a full load, the closer it would get to 60 hertz. But I'm not really seeing that. And so I don't know if there's a problem with one of the components. There's nothing in here to tell it 50 or 60 hertz. At least nothing I've been able to see or find. And that's it. But then again, you know, other than some things will run a little bit slower, and there may be some problems with weird things like clocks. Otherwise, we'll power most things just fine. So that's it. The next video will be a much more sophisticated and modern inverter. Later.